Direct recruitment for the post of postgraduate assistants physical education directors grade I 2018 to 2019. Subject Mathematics. Unit I Algebra. Groups examples cyclic groups permutation groups Lagrange's theorem cosets normal groups homomorphism theorem Scaly's theorem Cauchy's theorem Solo's theorem finitely generated abelian groups rings Euclidean rings polynomial rings UND quotient fields of integral domains ideals maximal ideals vector spaces linear independence and bases dual spaces inner product spaces, linear transformation rank, characteristic roots of matrices, Cayley-Hamilton theorem, canonical form under equivalence fields, characteristics of a field, algebraic extensions, roots of polynomials, splitting fields, simple extensions elements of Galois theory finite fields. Unit 2 Real Analysis. Cardinal numbers, countable and uncountable cardinals, Cantor's diagonal process, properties of real numbers, order, completeness of order property in our Cauchy sequence, maximum and minimum limits of sequences, topology of R. Heine-Borel, Bolzano-Weierstrass, compact if and only if closed and bounded, connected subset of Arlen-Miller's coupling theorem. Continuous functions in relation to compact subsets and connected subsets uniformly continuous function derivatives, left and right derivatives, mean value theorem, Bode's theorem, Taylor's theorem, Hospital's law, Riemann integral, fundamental theorem of calculus, Weber's measure and Weber's integral or largest integral of rounded measurable function, other sets of finite measure, comparison of measure and Weber's integrals, Riemann frequencies theorem, repeated integrals. Unit 3 Fourier series and Fourier integrals. Integration of Fourier series features theorem on C.1 summability at a point, features Lipsky theorem on C.1 summability almost everywhere Rees-Fisher theorem, Bessel's inequality and Parseval's theorem, properties of Fourier coefficients, Fourier transform in L, D, Fourier integral theorem, convolution theorem of Fourier transforms and Poisson summation formula. Unit 4 Differential geometry. Curves in spaces, Serret-Frenet formulas, locus of centers of curvature, spherical curvature, intrinsic equation helices, spherical indicatrix surfaces in view, pitch of regression, developable surfaces associated to a curve, first and second fundamental forms, lines of curvature, Mills line theorem, Gaussian curvature, Euler's theorem. Duplin's indicatrix, surface of revolution conjugate systems, asymptotic lines, isometric lines geodesics. Unit V Operations Research. Linear programming, simplex computational procedure, geometric interpretation of the simplex procedure, the revised simplex method, duality problems, degeneracy procedure, perturbation techniques, integer programming, transportation problem of linear programming, the complex programming problem, Hamming programming, approximation in function space, successive approximations, gate theory, the maximum and minimum principle, fundamental theory of gates, Turing theory, single server and multi-server orders, FGI, GMI, GGMI, orders, enlarged service distributions or Models in replacement theory, reliability, failure rates, system reliability, reliability of growth models, network analysis, directed network, max Fluke-Cut theorem, CP equivalent, probabilistic condition and decisional network analysis. Unit 6, Functional Analysis. Banach spaces, definition and example, continuous linear transformations, Banach theorem, natural embedding of x in x, open mapping and closed graph theorem, properties of conjugate of an operator, Hilbert spaces, on normal basis, conjugate space H, adjoint of an operator, projections and known as a Hilbert space in B space, orders and inverse inequalities, matrices basic operations of matrices, determinant of a matrix, determinant and spectrum of an operator. Spectral theorem for operators on a finite dimensional Hilbert space. Regular and singular elements in a Banach algebra topological divisor of zero. Spectrum of an element in a branch algebra. The formula for the spectral radius radical and semi-simplicity. Unit 7, Complex Analysis. Introduction to the concept of analytic function, limits and continuity, analytic functions, polynomials and rational functions, elementary theory of power series, Lorentz series, uniform convergence power series enables limit theorem, analytic functions as mapping, conformality arcs and closed curves, analytical functions in regions, conformal mapping, linear transformations, the linear group, the cross ratio and symmetry, complex integration, fundamental theorems, line integrals, rectifiable arcs, line integrals as functions of arcs, Cauchy's theorem for a rectangle, Cauchy's theorem in a circular disk, Cauchy's integral formula, the index of a point, with respect to a closed curve, the integral formula. Higher derivatives, local properties of analytic functions and removable singularities, Taylor's theorem, zeros and poles, the local mapping and the maximum modulus principle. Unit 8, Differential Equations. Linear differential equation, constant coefficients, existence of solutions Wronskian, independence of solutions, initial value problems for second order equations, integration in series, Bessel's equation, legendary and Rabide polynomials, elementary properties, total differential equations, first order partial differential equation, Chaplet's method. Unit 9, Statistics, I. Statistical method, concepts of statistical population and random sample, collections and presentation of data, measures of location and dispersion, movements and Shepherd correction calculate, measures of skewness and kurtosis, curve fitting by least squares regression, correlation and correlation ratio, rank correlation, partial correlation, multiple correlation coefficient, probability discrete, sample space, events, their linear, intersection, etc., probability. Classical relative frequency and axiomatic approaches, probability in continuous probability space, conditional probability and independence, basic laws of probability of combination of events, Bayes' theorem, probability functions, probability density functions, distribution function, mathematical expectations, marginal and conditional distribution, conditional expectations. Unit X, Statistics 2. Probability distributions binomial, Poisson, normal, gamma, beta, Cauchy, multinomial hypergeometric, negative binomial, Kihei's lemma, Law of large numbers, central limit theorem for independent identical variables.